Great. For those just joining us, thanks again for taking your time today to join us on our webinar series. I think this is webinar number 7 or 8 in the last few weeks while people have been out of their normal work patterns, let's say, with the current pandemic that's going on. So hopefully this is a good use of time, and the feedback so far I've had has been really good. And we're tailoring the content of these webinars now based on input from you guys. So if you have ideas of other topics you'd like to cover, this week's covered off with another Smart Tap webinar on tomorrow, actually, which is looking at how we plan and calculate ROIs for the Smart Tap water dispenser systems. So that's a webinar on tomorrow. Next week we've got a couple. One is on sales techniques, which has been asked for in some detail. So how can we use some sales techniques for solar pumping, and again, particularly with the difficult business environment at the moment, how can we add a lot of value to customers by using water pumps at the moment? So today's webinar is all about using sensors and how we can add sensors to our systems to add more value. So we are using the GoToWebinar software again. This has worked out pretty well for us. We have got everybody on mute at the moment, but if you've got questions as I'm going through, please type them in. You'll see in your webinar box there is a little questions area. You can type a question in, and what I'll do is try and answer as many of them as I can as I'm speaking, and then any that I can't get in the standard content, we'll have a Q&A session at the end, so we'll cover off those at the end of the session. Everything's going to be recorded today, so if there's anything that goes a little bit too fast, or sometimes the screen update's not quick enough on slower connections, then don't worry too much, because you'll be able to see a recording of this later this afternoon on PartnerNet. So go on to PartnerNet, there's a new webinar area there you'll see on the home screen. And if not, you'll get an email 24 hours time. So this time tomorrow, you'll get an email which links you to a recording of the webinar. Again, of course, you can share that with colleagues as well for anyone that's missing today's session. So yeah, let's get into the content. And what I want to talk about is how we take the LORENTZ blue box, the LORENTZ controllers, and how we really open up this box to add value to any solar water pumping system. And I guess one of the reasons that you're all here, hopefully, is that you already recognize LORENTZ as a good pump brand. So we're designing now for nearly 25 years solar water pumps, I think well recognized in the market and in the industry as making really good, high quality, long life products. We're renowned for our efficiency, so generally great solar pumps. But of course, having a great solar pump is maybe not enough today, and we need to be adding more value to customers. So let's talk about some of those things in a little bit of detail. So we know that we can produce and deliver really good water pumps to our customers, but let's think about what we can do going beyond just pumping water using solar power. So what are the things we can do beyond that? So with our smart controllers, and this figures across the whole range from the smallest PS150 product through to the PSK 100 product. So from PS2 at 150 watts right through to our PSK systems at 100 kilowatts. All of our systems will do all of the things we talk about here, so very consistent across the whole range. So the first thing that the pump systems are doing is they're measuring what's going on around them. They're recording what's happening. The pump controller is then analyzing the results. So it's saying, great, I've measured this. What do I do with it? And then they're acting on that information. So we can tell the controller to act on a specific piece of data that it gets. And we can use this information then to manage a water network. So this all sounds a little bit fancy and complicated, but what do we mean by managing a water network? We basically mean managing the water from the source, so from a borehole, from a pond, from a tank, managing the pressure and amounts through the network to the point it's delivered, and knowing how much has been delivered, deciding what pressure we deliver it at, deciding when we stop delivering water. So that's what I mean by managing the water network, from source to delivery point, managing how much water, at what pressure, at what time, all of these things the pump controller is doing for us. And this is really what I'm talking about. This is the value add on top of having a great solar pump. It's having all of those controls and features. And one way you might think about this, it's maybe a useful analogy, is thinking about the Swiss knife that lots of us carry in our pockets or in our toolkits. Probably 70% of the time, you're using this knife for its main cutting blade. Whether you're peeling an apple or cutting a piece of rope, you use one blade most of the time. And this is, it's a great knife for doing this. But what you also have in this knife is the thing that you can really meet every application with. And we should think maybe as the LORENTZ pump controllers as this Swiss knife. It's a great solar water pump, but actually it can do so much more if we want it to. And all of this comes in one very nice package that's available to you all the time. So keep this in your mind, the idea of the Swiss knife, and we'll run through some examples of how we can take, again, we're talking here about standard product, nothing added to it in terms of software or special functions. What we're talking about today is things that are out of the box available. So let's talk about a few of those things, and I'll try to run through this with a problem and solution so we can think about what we really can do with the LORENTZ controllers. So the first problem I want you to think about is, how can we manage filling a water tank that's 5 kilometers away from the pump? So as you all know, the real world doesn't always mean your borehole and a tank you're filling are next to each other. They could be at quite a distance apart. So putting the tank closer to the community that it's serving, to the animals it's serving, or to the crops it's serving, might be logical in the environment you're in, and it might mean that the source of the water is a long distance away. So how can we manage this? How can we get the pump to fill the tank but not overfill the tank and waste water? The solution is very simple. We take any of our pump controllers and we add onto it a pressure sensor, so a liquid pressure sensor, and we're going to use then the inbuilt pressure switch features which are included in the pump controller. And of course, as most of you know, the way we're going to access the configuration of these things is using Pump Scanner. Pump Scanner is the Android app, runs on any Android smartphone, and allows you to program the pump controller. So all we're going to do is take our pump controller, pressure sensor, and use some inbuilt features and functions that are inside the controller. Good, so we have our controller here, and we have our tank, which is quite distant. So we're 5 kilometers away. And of course, between the two, we're going to have a pipe. So the pipe is going from, in this example, a borehole to our filling tank. And what we're going to do is, in the tank, we're going to put a float valve. So this is just a very simple mechanical valve. As the level changes, the valve opens and closes. So a very simple mechanical device. So we've got no cable running 5 kilometers. We've just got a pipe running to a float valve. And then on our pipeline, obviously close to our controller, we're going to then install our liquid pressure sensor. So you can tell by its name, this is a pressure measuring device. So this is not a switch, this is actually a measurement device. And what this is going to do is measure the pressure in that pipe. It's going to measure the pressure in the pipe, and as the pressure changes, the controller can then act on the information it has. And we're going to very simply wire this pressure sensor in. So inside the controller, whether this is PS2 or PSK2, doesn't matter. All of the connections are consistent across the whole range. And we're going to wire this into one of the two analog ports that we have in the controllers. So we have analog 1 and analog 2. These are, as you can see, 4 to 20 milliamp ports. So they're analog ports. We can connect to either of these, it doesn't matter at this point. If nothing else is connected, connect to analog 1 or analog 2, and it's a 2-wire connection. So we just wire in the pressure sensor into our controller. And that's our physical installation complete. So we have 5-kilometer pipeline, a pressure sensor at one end with our controller, and at the other end we just have this float valve. So next comes the configuration. So we're going to configure the sensor now using Pump Scanner. So this is our Android app. It's available on the Play Store. If you don't have this, go onto the Google Play Store. You can download it. And all of the things I'm going to show you here, you can try these out. There is a demo pump, like a software demo pump within the Pump Scanner. You can play around with this, look at these settings, mirror what I'm doing today, have a play around with what else is in there. So there's a few other things on top of what I'm going to cover today. So the first thing we want to do in our Pump Scanner configuration is we want to configure the sensor. So we want to tell the controller that we have a pressure sensor connected to it. So when we configure a sensor, we want to go to our installation settings. So this is about setting up the hardware that we've installed. So we hit installation settings, and we're then going to say on analog input 1, which is where we've just wired it to. So we tick analog input 1 here. We're going to tell the controller that what we've just connected is a pressure sensor. This will become clear in the next slides why we're going to tell it it's a pressure sensor. We tell it it's a pressure sensor, and we tell the controller what the measuring range of this sensor is. So the particular one we've connected here is 10 bar. Of course, all of the sensors have on them their rating. What are they rated for? This one is a 10 bar sensor. So this will measure 0 to 10 bar of pressure. And that's it. That's the configuration done. So we hit save, and the installation configuration is done. So if we stop at that point, what will happen is the controller will recognize there's a pressure sensor, and it will display in Pump Scanner the pressure settings. So it will tell you real time what the pressure settings are, and it will also store those pressure settings continuously. So when it stores all of its other data, it's also going to store the pressure measurement. So it will give you your pressure measurement over time. You can come back in 3 weeks and look at what's been happening to the pressure over time. But actually what we want to do is we want to tell the controller to do something with that information. So we want to configure the behavior of that sensor and the pump with that sensor. So what we're going to do is go to our feature settings. Down here we go to feature settings, and we're going to tell the pump now that we want it to be controlled by pressure. What you can see from this screenshot is actually when I've gone to control by pressure, it's saying, on analog 1, you've configured a pressure sensor, so I'm going to give you that option. So the software helps you all the time to make the right choices. So it says, great, we want to control something by pressure. You've got a pressure sensor on analog 1, so let's choose analog 1. And in this case here, the function we want to use is pressure on and off. So what we're going to tell the pump to do is we want you to switch the pump off when the pressure in this pipe gets above 6 bar. And we want you to switch the pump back on when the pressure in the pipe drops below 2 bar. You can see there are some more options below here, like you can set a delay timer and things. So the idea, of course, here is what we want to do is say, pump water, measure the pressure in the pipe. When we see this valve, float valve closing, the pressure will increase. When we see the pressure hitting 6 bar in the pipeline, we switch the pump off. When the pressure drops in the pipeline, the valve's open again, the pressure drops, we want to switch the pump back on again. So this way we're getting very accurate control of the pump. Let me explain that a little more. So if we go back to our pipeline, our pressure sensor, and we see the valve at the end, we would see here that we have our measurement going on. You can see this live on Pump Scanner. You'll be able to see the pressure measurement readings. As the tank fills, of course, the float is going to come up. The valve's going to close. The pressure in the pipe's rising as the valve closes. And when we hit 6 bar in the pipeline, the pump stops. So this tank 5 kilometers away then stops filling. So the pump stopped. The community used some water for the tank, so the level drops down again. The pressure in the pipe then drops. So as the valve opens again, the pressure drops. The pump will wait until it sees the pressure in the pipe down to 2 bar, then it would restart again. So you've got a really simple way of controlling filling of a remote tank. Now you might be saying, actually I could do this though with a mechanical pressure switch. And yes, you could, but I think for anyone that's ever done this with a mechanical pressure switch, you know the problems. Trying to set them accurately is really trial and error. Seasonal adjustments from temperature, etc., become problematic. Trying to get any degree of accuracy by setting 2 springs is very hard, and the life of a pressure switch is typically very short. Remember, this solution here has got no moving parts. It's a pressure device. It can be set, as you can see, very accurately, and you also have the benefit of being able to measure over a long period of time exactly what's happening in the pipeline. So you could even see leaks and things by looking at the pressures here. So very simple way of using a pressure sensor to fill a tank. Let's get a bit more complicated now. So let's think about what if we wanted to not fill one tank, but we maybe want to fill 3 tanks from one pump. We could also do filling multiple pumps to multiple tanks, but let's try and keep it relatively simple. And we'll look at how do we have 3 tanks, maybe set at different elevations, different sizes, even different locations. How could we fill these by using one pump? The answer is actually we're going to use exactly the same equipment as we used in the first example. We're going to use a controller. We're going to use a liquid pressure sensor, but we're going to use a slightly different function here where we're going to combine constant pressure and a pressure switch. And I'll explain why this is. I'll explain how we do this. So let's use this schematic to explain what we're trying to do here. So we're going to fill 3 tanks or 3 ponds, it doesn't matter. We've got our pump in a borehole. We've got our pressure sensor in the pipeline connecting to our pump controller. And then we've got 3 float switches, 3 float valves, 3 float valves in each of the tanks. So this is very similar to the first one, but what we're going to do is fill 3 different tanks or ponds at different elevations and different sizes. So we have our float valves installed, we have our liquid pressure sensor, and exactly the same as the first one, we're going to wire this into our analog port. So same sensor as before, we're going to wire it into analog 1 or analog 2, doesn't matter. So exactly the same setup as the first scenario. But actually this solution, if we left it exactly like the first scenario, we might run into a problem. And the concern in this kind of environment often is, as we see each of the valves closing, so maybe this smaller pond at the top right fills first, as that valve closes, then actually you increase the pressure in the pipeline to the other 2 outlets. So if you're basically restricting the flow of your pipeline here, and you would increase the pressure in the pipe. And of course, an application like this could be really fairly serious flows, a lot of water going through, a lot of pressure possible from the pump. And so what we could get to the point is where we even damage a pipe. So we have a couple of options. We either have to kind of turn everything down and fill them slowly, but that's probably not a good idea. We want to get the tanks filled as quickly as we can while we've got sun. So what we want to do is think about how can we protect our pipe work. And we're going to do this by using a constant pressure feature along with our pressure switching option at the same time. So we're going to have both things. So let's have a look at how we would do that. Good. So let's we've installed our pressure sensor sitting in the line there close to the pump controller. We've got our 3 long pipelines going off to remote tanks. We've got the float valves installed in the tanks. So let's do the configuration of the sensor. Again, this is easy now. So we're going to go to our installation settings. We're saying it's a pressure sensor. We're saying its measuring range is 10 bar. So again, exactly the same as the first configuration for the hardware. And then we want to configure how we want the sensor to behave in this new environment where we're filling 3 tanks up. So we're going to go to our feature settings. It's a control by pressure application. Yep, good. And it tells us again we've connected to analog input 1. So again, it's helping us through the process. And this time we're going to choose constant pressure application. So what we're going to tell the pump to do is aim for 4 bar of pressure. Ramp speed I'll leave for a moment, but this is basically the ramp speed is going to tell the pump how quickly it should hunt to get to the desired pressure. And I'm also going to set a maximum pressure threshold at 6 bar. And there's a bunch of more complex advanced features in here. I can do overshoots, I can do different things, but let's keep this quite simple. We're going to tell the pump to stay at 4 bar, and then we're going to say when you hit 6 bar though, stop. So the idea is that we keep the pressure in the pipelines, doesn't matter if it's 3, 2 or 1 of the valves open, we want to maintain a constant pressure in the pipework so nothing gets damaged. Only when we see something over 6 bar, i.e. the last the last valve closes and all are closed, do we want to switch the pump off? Good. So let's try and explain this. I think it hopefully makes a little bit of sense to you. So what we're going to do is the pump starts running, and the pump's going to speed up. Of course, the only thing the pump can do is change its speed to adjust pressure. So what it's going to do is speed up, and it's going to speed up till it reaches 4 bar. Maybe with all 3 valves open, it can't even reach 4 bar, but it will be trying to do this. So it will be going as fast as it can, pumping as much water as it can to try to get to 4 bar. It maybe reaches 4 bar, depends on pipeline lengths, all the other things you understand in fluid dynamics. So as each of the valves closes, so each tank fills, one tank fills, the valve will close and the pressure in the pipe will increase, of course. So it will go up 5, 6, up maybe 4, 4.5, 5 bar, and the pump then will slow itself down to get back to 4 bar. So it's going to keep, even though there's now only 2 open, it will keep the pressure constant to make sure no pipework's damaged. And then as the last one closes, of course, the pressure will increase and the pump will switch off. So it will do this quite quickly. There's quite a lot of settings that can be changed to allow for long pipe works, differing pipe sizes, changes in elevation with back pressures. All of these things are really easy to set up. Most of these things really need a bit of measurement on site. The great thing is you use the pressure sensor itself to look at the measurements, look at the behavior of the pump, and then it makes the settings fairly easy to do. Let me just explain in a chart how that looks, just so that you can get a feeling for it. So if we imagine this red line is the pressure, we would see it starting at 0, and as the pump would speed up until it reaches 4 bar pressure setting, it would then stay constant pressure. We would then see one of the floats close. Of course, this creates a pressure spike. The pump would then see this and then ramp itself back down, so actually reduce speed, maintain 4 bar again. Second float valve closes, again another spike. We see another spike. The pump again would slow itself down to 4 bar. Then we see 6 bar spike as the last one closes. The pump will switch off. So that's the way you can use the inbuilt applications. Again, designed very simply. I think you can see very simple to use, very simple to access. You can use this really to be quite creative in the way you control water networks, and trying to do this in any way apart from using these kind of controls is, I would say, almost impossible. There isn't really an alternative to doing this. You couldn't do this very simply with just a pressure switch in this case, because you would have to really upscale your pipe work to stop any damage. So this allows really quite complex solutions to be designed, allows you to fill multiple tanks, allows you to have multiple pumps going to multiple tanks. This is really quite flexible. So I know this stuff's quite complicated, but please let's keep going through. So if I just summarize the use of the pressure sensor there, you've got this accurate control for switching or constant pressure. So we talked today about tank filling and pipe protection. Of course, you can use the same function for things like process input. So maybe you have a specific pressure you want to go into a process like water treatment or an industrial process. You can use the same controls, and you can really use this for managing these complex dynamic pressures. So if you have people turning valves off at different parts of the network, if you have all of these things to consider, again, if you even in irrigation systems where you're closing off different parts at different times, you can really make sure you maintain constant pressures throughout so that you're not going to damage any irrigation equipment, pipe work anywhere. start damaging valves or anything. And of course, don't forget, all of this data is being recorded in the pump controller. So you have the history of what's been going on. Again, if you're seeing certain behaviors from a troubleshooting point of view, you can go back and look, what were the pressure settings doing at this point? Did someone park a truck on a pipe somewhere? You get a good feeling for what's going on. Good. So let's look at another problem, problem 3. We're going to look here a little bit about how we can monitor and manage our groundwater sources. And this is one example. How we can look at what's happening in the borehole rather than looking at the delivery network. Let's look at the borehole, or look at ponds, water sources we're looking for, or even look at how we can measure levels in tanks. So rather than just saying, is my tank full or not, we can actually start to look at how much water there is in a tank, how much water there is in a borehole, and get the pump to act on that data as well. So in this example, we're going to use, again, a controller, but rather than a liquid pressure sensor, we're going to use a level sensor. So this is a liquid level sensor, and we're going to use some different controls in the pump controller, and we're going to use control by level feature. So again, this is not too dissimilar, but a really exciting application that we can use with all of our pump controllers. So let's have a look at this. So here we're going to use an example of a borehole, but this is a borehole. It could easily be a tank. It could be a river. It could be, again, don't always think about rural applications. Think about how we can also use these controls in more industrial processes. Increasingly, we're seeing things like food processing. We're seeing applications like textile industries, this kind of thing, where there's a lot of water use, particularly in more rural places where they're using solar pumps for these kind of applications too. But let's stick with one we all know well and look at a borehole. So what we're going to do in this case is we're going to connect a liquid level sensor into our pump controller. So this device is still wired to analog 1 or analog 2, it doesn't matter. You can choose a free one. And this sensor is actually going to measure how much fluid, how much liquid is above the sensor. So it's basically going to measure how much water there is above the sensor. And it's going to do, it's actually a pressure measurement, but it's going to give us this result in meters or feet. So it's going to tell us how many meters of water is there above the sensor. So yeah, a slightly different measurement point. What we have with this sensor slightly different is because this is submerged, then what we have to do is we have to balance this sensor back to the atmosphere. The reason this has to happen is, of course, this is a very sensitive measurement that it's doing, and even atmospheric pressure would change significantly the measurement. So if you imagine it's a very low pressure cloudy, stormy day, what we don't want to see in our results is it looks like there's less water in our borehole. Same if it's a high pressure weather pressure coming in. What we don't want to see is that result changing. So we have within this cable actually a small capillary pipe which balances the sensor back to atmospheric pressure. This means it's always very accurate, doesn't need calibrating, doesn't matter what altitude you install it at, it's always going to be accurate. So again, very simple to install. We just wire it into analog 1 or analog 2. So let's look at how we set up our level sensor. We're going to do something pretty simple here. We're going to say, actually, let's measure and monitor the water in the well. But let's also get the pump to be controlled depending on the level. So you've probably got the idea of this now. configuration of the sensor is easy. We go to our installation settings to configure the sensor. And of course, this time, actually, I wired this one to analog 2. So it's now popping up analog 2 and it's saying sensor, it's a level sensor, and our measuring range on this particular sensor is 10 meters. So again, all of the sensors have on them their measuring range. They have a kPa and a meters, both are included on there. So setting them up is really easy. You can look at the sensor. This one says, great, I'm a 10 meter measuring range. That's the configuration done. So at that point, you will now see on pump scanner, it will say, great, you have 5 meters of water in your well. You have 4.3 meters in your tank. It tells you exactly how much liquid there is above the sensor real time. Again, if you move this in a borehole, you pull it in and out, you'll see the level changing real time. So what we want to do in this example here is I want to switch the pump off when we get down to 1 meter. So I want the pump to run, but actually I want to make sure I always keep 1 meter above my sensor. So I don't want the pump to run dry, of course. And I want to make sure that I don't over pump my borehole. So I'm going to say, great, I want the pump to switch off when the reading is below 1 meter. And I want it to come back on when the well has recovered and we get back to 1.5 meters. So I just set this here, analog 2, pump off below 1, pump on above 1.5, save. And that's it. So that's done. We would see something like this in the display. Then you can see I've got limits set. 1 is my bottom, 1.5 is my switch on. So you can see this, and you can see then the sensor is actually recording here 15.5 meters. So again, this has of course been done on demo software here, but you would see then the real level coming from the well. So really easy to set up. Behavior, I think, yeah, makes complete sense. You could do this into a tank. Very simple to use. I've got a couple of questions which have come in, which are relating to these topics. Yeah, so a couple of questions. One that's been phrased 3 different ways, but if I just summarize the question, hopefully it addresses everybody. What about hysteresis? So is this a problem? So of course, if you, depending on the settings you make, if you have a couple of options. If you said switch in this example, or in the pressure example as well, if I kept saying, well, switch off when I get below 1 and switch back on when I get to 1.05, yeah, there will be quite a lot of on and off switching of the pump. Yeah, because you're really telling it to go between 2 very narrow parameters. And this could result in the pump switching on and off. Again, for all of our products, this isn't a problem. So if you look at the PS2 range, you can switch them on and off as often as you want to, but it's actually probably not good practice for pipe work. So the pump's okay, but even for pipe work, lots of switching on and off, probably not a good thing to do. So you've got a couple of options with pressure and level you can do. You can obviously set the on and off parameters a bit further apart, so you can move them further apart from each other. So in this example, I've got 0.5 meter of recovery. I could do the same with the pressure. I could move them further apart. And the other thing you can do is you can also set in, both for pressure and levels, you can set a delay between your switch off and switch back on. So again, if you've got a 5-kilometer pipeline or something, switching on and off just because of pressure fluctuations in the pipe doesn't make sense. You actually set your switch off pressure reasonably high, and then maybe you set 20 minutes or even half an hour timer. You have to look at the local application to think and say, okay, once I've switched off, this only happens once every 3 days. Let's leave the tank for half an hour before we start pumping again. So in all of the settings here, you will always have delay timers, as well as being able to move the switch on and switch off parameters apart from each other. So I hope that answers those questions around the hysteresis. Some questions about pressure generally, about where you put pressure, where you put your pressure sensors. Again, if you think of your pipeline as being a pressure vessel, actually it doesn't matter really whereabouts you put the sensor, the pressure is going to be constant, constant throughout. So whether you're putting it at one end of the pipe or the other, actually the pressure is logically the same. You're always going to have your pressure sensor, of course, close to the controller, which is typically closer to the wellhead. You're going to measure your pressure there. Otherwise, you might use a different method. If it was the other end, you might just use a simple float switch. Yeah, so with a distant pressure measurement, you're always going to put your pressure sensor close to your controller, close to to the wellhead typically. Good. Yeah, some questions about measuring other things. So we're going to be making some announcements at the end of the summer on additional sensor inputs and for measuring different things, and ability to configure different sensor types. But I'll hold off on that for the moment, and we'll talk about releasing that say in the summertime, where we're going to add different sensors and things to. So one example is turbidity, temperature, maybe soil moisture, all of these different things that you might want to measure as part of the system. We're going to be adding some more sensors, sensor inputs, different ways of doing this. So you're going to see this later in the year. It's part of our ongoing development. Yeah, so let me explain a little bit about the level sensors. So there's a couple of things we should think about with the level sensors. So the level, this device is the level sensor is a pressure measuring device. So it's looking at the increased pressure here compared to here. So it's looking at the increased pressure. And obviously the increased pressure is caused by the weight of water, if you like, acting on that sensor. So that's what it's measuring. So wherever we set this, we don't have to set this at the pump level. We can set this anywhere in a water column. And what it's going to do is measure from itself up. So let's say we have let's really say we have a very, very deep well, maybe 100 meters deep and 100 meters water column. And actually, for whatever reason, our pump's sitting down there happily in the well. But what we don't really want to measure the 100 meters. What we want to do is measure only the water level that's likely to change. So maybe this well has a drawdown of 10 meters and a seasonal difference of 5 meters. Let's say something like that. So all we'd really be interested in is measuring from 20 meters below the surface to the top, because that's the only thing that's ever going to change. Actually, the 80 meters below, which is static, that water level is never changing. It's not very interesting to measure. So what you'd do in that case is you'd pick a sensor that measures 20 meters. And the reason you do this is twofold. Firstly is if you measure a smaller range, so if you measure 10 meters rather than 100 meters, you're going to get 10 times the accuracy. So there is just because of the analog to digital conversion of signals here, there is a resolution of these sensors, and it's an 8-bit sensor for those of you that want to know. So we basically have 255 measurement points for each range. So if I put a 100-meter sensor in, I've got 100 divided by 2.5 by 255, so roughly 40 centimeters is my minimum measurement point if I want to measure over 100-meter distance. If I measure over 10-meter distance, then I can measure in 4 centimeter increments. So you see that the accuracy changes, or the accuracy remains the same. Actually, the granularity of the measurement changes depending on the sensor. So we're going to try and find a sensor that measures the amount of water that's likely to change. And the second thing is you also, because this has, as I mentioned, a pipe inside it, then this is not a cable that you can splice. So when you buy the sensor, it has a cable attached to it. Again, there's various sensors, various cable lengths that you can buy off the shelf. In some of our distributors also will do custom cable lengths on these. It's obviously it's quite a complex process to connect a cable and seal it. It's a factory process rather than something you do in the field. So you buy the sensor with the cable length on it. So choosing the right sensor is important. The data is of course stored, so you can see what the aquifer is doing through the year. You can see the seasonal changes. You can look at the trends to say, great, what's the water level doing? And this is a really important feature for customers, is if they can see this year the water level's really going down, this gives you a couple of options. It might be that you could go in and reset the pump and move the pump down in the borehole if it's able. Or you can do some emergency planning to say, look, in 6 or 8 weeks' time, it looks like we might run out of water. Let's make a provision for the community by trucking some water in, doing whatever we need to do. Or maybe we even think about drilling a new borehole for the next year. So what's really important here is that this data can be used by the customer to plan ahead. Of course, if we're talking about governments and NGOs, they can look at what's happening, monitoring the groundwater sources. Again, in many countries, we see governments even funding this measurement activity. In some countries, you aren't allowed to drill a borehole, particularly for irrigation now, without having measurement in place, particularly in water scarce areas. So this is an important feature. Good. So a couple of things to think about with the LLS. So it's about accurate measurement of levels. We can use it anywhere. So our example's in a well, but it could also be in a tank. So we could use this. We could use this in the same way that we want to use it for filling tanks. So we can run the pump when the level's below this. Stop the tank Stop the pump when the level gets to this high. If we want to fill a tank, for instance. So remember, the controller is always recording the levels here as well. So this data is stored. You can look at the long-term trends. The other thing you can use this for is you can use this for dry run protection. So where you've got, for example, particularly dirty water or difficulty using a standard well probe, because this is a mechanical device. Maybe it's lots of algae in the water. Maybe it's snails or other things that cause problems with mechanical devices. Then this is non-mechanical and can be used in really quite dirty water. It can be installed vertically, horizontally, doesn't matter. It's going to measure the amount of water above it. Yeah, remember recording those. Good. So let's think about what else we do with this data. So of course, our pump scanner app is always going to give us access to this data. So the data is stored within the controller. Again, depending on the settings you've got, this is data capacity for up to 30 years. Typical default settings give you 5 years of data recording within the controller. So we have a lot of data stored there. And the way we access that is go to the pump controller, connect using pump scanner, and obviously this data is pulled via Bluetooth, and then you can view it all in pump scanner and see what's happening. The other thing we can do, of course, is we can connect a PS communicator to the pump controller. So this is our remote communication device, and then all of the data near real time will be sent through to our pump manager or global application platforms. So Pump Manager is the remote management, cloud-based remote management system we've been running for the last 5 or 6 years. Global, LORENTZ Global is our new cloud-based management system, which we're transitioning customers to. So we've got customers on both. We're transitioning them onto the new platform through this year, and you'll hear more about Global in detail shortly. So yeah, I'll use screenshots from Global today, but Pump Manager and Global are giving the same functions. The key is all of the data is then transmitted into the cloud. You can then look at any device real time, get alerts from it, tells you the levels. You can see the levels online. So for a particular pump here, I can see what it's doing real time on the remote platform. This is actually data I pulled this morning, so this is really up to date. This is a pump in Thailand this morning. You can see the pump was running, and you can see what it's done over the last 24 hours in terms of pumping. So this particular one has pumped 47.56 cubic meters. It run for 8.74 hours, and it generated 8.2 kilowatts of power. So you could see what it was doing. You also could see more technical data, and again, you would see the levels. This particular one doesn't have level sensors on, but if it had level sensors on, then you would see the levels. So you could see minute by minute, second by second, exactly what the pump's doing. So this data is sent by default every 10 minutes. So we have, say, near real-time data available for all of the parameters that you see in Pump Scanner as well. And of course, all of the settings you can also do remotely. So as long as you have the rights to do that, it's obviously rights managed, some of these functions. You could change the installation settings. So if someone had gone to site and configured a pressure sensor incorrectly, or the person visiting site wasn't comfortable with configuration, they could install it and then you could configure it remotely. So all of the functions that are available locally are available remotely through that platform. So yeah, a couple of other questions I'll just pick up on while we're there. So level sensors, yeah, so a level sensor can be used as a well probe. So you can use the liquid level sensor as a well probe. Again, you would just set to make sure that the pump switches off before the pump runs dry. So in that case, you would obviously install the level sensor above the pump, and then you would say, great, when I get to 0.5 meter, 0 meters, 1 meter above, switch the pump off. So it can be used there for pump protection. Horizontally, good. Okay, that's most of the questions. There's a couple of specific ones, and anyone that's not got the question answered so far, the reason I'll come back to you directly on some of those. So, yeah, what we've looked at in those 3 examples, hopefully, is starting to get you to think that you can use the pump systems here to do some quite smart things. And one very positive thing for you is you can really do this across the whole range. So everything we've talked about today, you can do this from a PS2 150. So a really quite small system still has all of these features and functions, right through to the PSK 2100, so 100 kilowatts. It's exactly the same. The design is the same. So using Compass to design the systems, installation is the same. So of course, the voltages get a bit hairier as you get towards the large systems, but if you can install a PS2 150, you can also install a PSK 2100 because all of the configuration, all of the settings, everything's exactly the same. So if you learn any of our systems, you can go through the whole range. And you have the same management functions with Pump Scanner, with Pump Manager, with the global platform right across that range. So this really is a learn once and serve any customer. So yeah, what I would like to say is let's think really now about how we can turn these great features and functions that we have inbuilt. This is not something you have, of course, sensors you have to add on, but all of the software features, all of the functions are really built into the product. So today we've talked about level sensors and pressure sensors, but we can also connect water meters, so we can control the pump by an amount of water. So we can tell the pump, please pump me 50 cubic meters today and then stop. So we can do that. We can also, with the inbuilt features, control external devices. So we have outputs on all of our products. So for instance, if we want to connect a chlorine dosing pump, we only want the chlorine dosing pump to run when the pump does. So we use the output settings in Pump Scanner to do this. So we would just simply set that to say, switch the output contacts when the pump is running. So again, it's like 2 clicks in Pump Scanner really then does something that's quite complicated to do. So this avoids the customer having to add more equipment, more complexity. We can really use the LORENTZ controller here as the heart of the water system. So when I go back to the beginning of my presentation, we talked about the Swiss knife. What we're giving you here is this great daily tool, which is a fantastic solar pump, but you have also in it, if you need to use the screwdriver or open a bottle of wine, you've got that in your pocket with the Swiss knife, and that's really what our pump controller is doing. It's giving you all of these extra features and functions as well as being a fantastic solar pump. And this really does, add a lot of value to your customers. And think about all of the additional hardware or complexity you would have to add to a standard solar pump system to do some of these things. Yeah, you'd be building control boxes, you would be building custom controls, you would be putting relays together, all of these things that might seem like a good idea on the day, but causes you a problem in the long term, causes your customer a problem in the long term, and actually really complicates things. What you could see from the configuration today of these features is it's typically 1 or 2 clicks and it's done. It's also using the same language that you use of pump on, pump off, set the level. It's not complicated. It's really accessible for people to use. So it's a heart of the system. We have those sensors. With the sensors, then we have the built-in applications to use them. So the control by level, control by pressure, control by amount of water. We can connect locally using Pump Scanner, and we can connect globally using Pump Manager or the global network. So this really brings all of that information, really valuable information, to your customers. And if we're doing it remotely, it's actually proactively delivering it to them. So you're telling them when the well's getting below a certain level, telling them that a tank's full, telling them that a tank's empty. So all of these alerts and things can be configured as well. So yeah, please think about how you can use these different things. There's a few questions about dosing pumps. Every time I mention dosing pumps, I seem to get lots of questions. So let's talk about the dosing pump topic. So the first question is, do we manufacture dosing pumps? And the answer is no. This is actually on our one of our development lists, because we know that chlorine dosing is really a problem for lots of people. Doesn't seem to be many good solutions for dosing pumps that people really love. Of course, there are mechanical variable flow dosing pumps, like I'll mention Dosatron, for instance. People have mixed views of them. I always thought they were quite a nice idea, but I'm told by lots of my NGO colleagues that they cause them terrible problems. There are, of course, lots then of electric dosing pumps, again, relatively expensive and typically need their own power supplies. They need battery backup and chargers and other things. So we're thinking about chlorine dosing all the time and how we could do things a bit smarter, but we don't have a product. Let me explain the how we would integrate to a dosing pump. So we can do a couple of things, of course. Is one, we can share a water meter with a variable speed dosing pump. So this is possible, adding in a couple of diodes to do this. I think we have a technical article on this, how to do it. If it's not published, I'll make sure it is actually. I'll put that on my list to make sure it's published, of how you can share a water meter between two products. Avoid installing two. The typical use case with the dosing pump would be, you obviously don't want the pump to dose unless but we don't want the dosing pump to run unless the solar pump is running. So in that case, what you would do is you would use the output contacts. So normally a dosing pump has a input contacts to run or not run. You would use the output switching output on the PS2 or PSK2, and you would configure then in the output settings. Again, please go to the feature menu here. You'll see that there's an output setting, and you would say only switch the output when the pump is running. So only when we know we're pumping water, not on, but actually pumping water, we would then switch the output, and then you could switch the dosing pump on with that output. So this means that the dosing pump won't run unless our pump is physically pumping water. Again, if you start to think about matching this with a constant flow as well, you could do the same thing. So if our pump's only going to run when we can reach a certain flow rate, then you could then switch the dosing pump on when that flow rate is running. So you have ways of controlling the pump like that. You can also use the output for some other things, like you can base it on sun sensor outputs, other things. So you can get quite creative about how you use that output switching. The question here about power supply. We don't have a power supply for a dosing pump. Again, this is one of the things that is kind of part of our thinking here. How can we do this? What can we do smarter to serve dosing pumps or produce a dosing pump that fits much better with solar pumps? So we're thinking on that. I notice we're just over time. Sorry, we've run over a little, but I'm still here for any more questions. There's a couple more coming in. A question about a question here about how you can see the levels. Any sensors that are configured, when we look at the global or pump manager platform, what you'll see is an extra. The measurement will be given real time to you, so you'll see the last level recorded, but you'll also see then trend lines. So you'll be able to go back for a year, 2 years, 3 years, and see exactly what your levels are doing. So you can see this for very short-term things, like you can see the drawdown of the well. So as the pumping starts, you'll see the level drop. You'll hopefully see it stabilize through the day then, and then you'll see it rise at the end of the day, and then you'll see the next day. So you look over a long term here. What's the seasonal variation? What's the long-term variation? So you can really see exactly what your aquifer is doing over a long period, and that's available to you on Pump Scanner and also on Pump Manager or Global. Okay, so I'm going to bring the event to a close for today. We're 6 minutes over time. We thank you for joining us today. Tomorrow we're going to be talking about smart tap water dispensers. If you haven't registered, please think about registering for that. So tomorrow we're actually going to look at example planning for communities. So thinking about how many smart tap water dispensers we would install for a certain community size and how you can do that. We'll be talking about the costs and ROIs. So we're looking at ROI calculations on the smart taps as well, and giving you some examples yeah, some example ROI calculations as well. So this will be about planning, how to work out how much equipment you need, how to think about even positioning and placement of dispensers, and how that would work in communities. So if you haven't, and that's interesting for you, then yeah, be great to talk to you tomorrow. Thanks very much for taking the time today, and yeah, hope to see you again soon. Bye-bye.